Hello class. So let us see the monomeric ingredient in the final polymer composition. So this is one of the most important question. It comes for around 16 marks every year, and if you know this, then probably your 16 marks is guaranteed. So let us see what is it. What it is. In addition to the chemical composition of the polymer molecule, that is CH2CHCl, which is of vinyl chloride monomer, the final commercial composition often contains monomeric ingredient whose chemical composition has also important effect on the properties and application. So sometimes, apart from the chemical composition of the polymer itself, there is some final commercial composition. Okay, so these also play an important role in their properties and application. So the monomeric ingredients, they are called. So these are of two type monomeric ingredient. As the name suggests, monomeric ingredient of final polymeric composition. So this monomeric ingredient is of two type. Number one, impurities remaining from the original polymerization reaction, and number two, monomeric additive purposely introduced during compounding to modify composition and final properties. So first we will see impurities. The polymerization reaction may leave a number of impurities in the final composition. Like I said in third semester, in bulk polymerization there is hardly any impurity, but in solution there is an impurity. In suspension there are impurities. Okay, and they may have a variety of effects upon the properties and the uses. In general, volatilization or leaching of such impurities can be responsible for shrinkage or creasing. In addition, each type of impurity has specific effects which deserve individual consideration. So there are various type of impurities. Number one, monomer. The residual unpolymerized monomer often remains tenaciously in the final polymer. So sometimes you get a final polymeric product, but polymer is nothing but a rapid addition of monomers, and the chain length is formed of monomers. But there are some monomers which don't get polymerized, but still they are there in the final polymer as impurity. This generally softens its mechanical and thermal properties, causes poor color stability during aging, ethyl malate, and produces undesirable odors, styrene and acrylic esters. Some residual monomers may even be very toxic, particularly isocyanates, vinyl carbazole, and chloroacrylate. So as you can see, some are toxic also, and some are producing bad odors. So a commercial product should not have any odor, otherwise the customer won't buy it. Then solvent. This must be in the solution polymerization, because in solution polymerization there is solvent. Residual solvent generally softens mechanical and thermal properties and causes odor in the finished plastic. In some aromatic hydrocarbon solvents may also cause toxicity. These problems are particularly troublesome after certain solution polymerization and coating operations. Okay, so solvent is also impurity. So two impurities we have seen, monomer and solvent. Then water. Water may remain from the polymerization and washing steps in the preparation of the polymer. So polymerization, sometimes we use water, so it may remain in the final polymer product, and in the washing steps in the preparation of the polymer, or it may be absorbed from atmosphere or immersion during storage and use. In any case, the presence of moisture in many polymer causes volatilization problems during processing. It also softens mechanical properties, lowers dimensional stability and electrical properties, and it is the starting point of hydrolytic degradation of the polymer molecule. This is particularly important in polyamides previously covered in the section on hydrogen. So water can cause dimensional instability. So it can, the dimension of the polymer will not be proper because of the presence of water, and secondly it can also be responsible for hydrolytic degradation of the polymer molecule. Now chloride ion. Now this chloride ion, the presence of residual chlorine ion as an impurity in the polymer can be responsible for poor electrical properties. In combination with acidic condition, the resulting HCl can also produce serious conversion. In general, the presence of mobile ions can contribute to electrical conductivity, thus lower insulating ability. So we all know plastic are good insulators because they don't have any ions in them that can pass the current. But due to chloride ion, which is a highly electronegative, so it can produce some mobile ions and that can contribute to electrical conductivity, therefore lowering insulating ability. Now catalyst and initiator. We all know during polymerization we add catalyst and initiator. Okay, रेसिडुअल कैटलिस्ट एंड इनिशिएटर मीन्स जो बच गए, जो कंज्यूम नहीं हुए, रेसिडुअल or the decomposition products in the final polymer, often peroxides or transition metal compounds, may be harmful to thermal stability, electrical properties, weathering. Some initiator residues may also be toxic, particularly those from dispersant. Surface active agents used in the dispersing the polymerization reaction can hurt thermal stability, electrical properties and weatherability. Certain dispersant, particularly methyl silicones, can also be very detrimental to post decoration operation such as painting. On the other hand, surfactants may be a crucial value in many foaming and coating operations. So as you can see, like I said, catalyst and initiator, organic azo compounds, particularly those from organic azo compounds. Okay, then you can see next one, that is dispersant. Okay, let's see dispersant. Surface active agent used in dispersing the polymerization reaction can hurt thermal stability. We all know in suspension and emulsion polymerization we use surface active agent to keep the monomer molecule in the colloidal form, prevent it from settling. So but the residual dispersant can hurt thermal stability, electrical properties and weatherability. Certain dispersant, particularly methyl silicones, can also be very detrimental to post decoration operation such as painting. So because of the dispersant, the polymer cannot get painted, or it can produce some detrimental effect. On the other hand, surfactants may be crucial value in many foaming and coating operation. So the impurities are of following types, as you can see: 1 monomer, 2 solvent, 3 water, 4 chloride ion, 5 catalyst and initiator, and 6 dispersant. So while explaining the impurity as a monomeric ingredient, you have to explain these 6 topics. Now additives in compounding. So this also comes in the monomeric ingredient of final polymeric composition. So you have to consider additives in compounding also. The addition of monomeric additive in compounding to produce final commercial composition and properties is very common and useful technique. At this stage, it should be recognized that such monomeric additive will often have lower chemical resistance than the polymer itself. In addition, each type of additive has certain important special effects which should be considered. So we all know additives we add for polymer to enhance its properties, but they have a lower chemical resistance as compared to the polymer itself. Now plasticizer. We have already seen plasticizer. The addition of monomeric liquid plasticizer to improve processability or flexibility of polymer is a very common practice, especially in polyvinyl chloride and cellulose ester. These must be sufficiently similar to the polymer in polarity and hydrogen bonding to be miscible and compatible with it, and low enough in volatility and diffusibility to remain fairly permanently in it. So all these topics we have considered in the mechanism of plasticizers, that polarity and hydrogen bonding should be there to be miscible with the polymer, and it should have low enough volatility and diffusibility to remain fairly permanently in it. Monomeric plasticizers are relatively non-volatile but still somewhat fugitive when heated or aged for long periods of time. Most of them are less solvent and chemically resistant than the polymer to which they are added, and many are extractable by soapy water, gasoline, motor oil, fonds, or dry cleaning solvent. Most of them are combustible and lower the flame resistance of the total composition. Also, many of them contain structures which are less resistant to heating than the polymer to which they are added. And finally, some of them are fairly toxic and it should be used with caution, where they could be extracted by food, drugs, or cosmetics. Then stabilizers. Substances which can help to stabilize the polymer against heat or ultraviolet degradation are extremely useful in many polymers systems and are very often added in small concentration for this purpose. Their effect on electrical properties may be good or bad depending upon the specific stabilizer. For example, lead stabilizers and vinyl electrical insulation, although they are relatively polar. These are the stabilizers for polymer, some examples. Yeah, this one. Relatively polar and ionic in nature actually improve the volume resistivity of the resulting insulation, probably by absorbing ionic impurities which otherwise would have conducted electricity. Phenolic type antioxidant may stabilize the polymer against heat and yet be sensitive to ultraviolet light, and thus sensitize the polymer towards ultraviolet light degradation. Such additive may also interfere with clarity if they should happen to be incompatible with the polymer. Some of them affect color, particularly certain ultraviolet light stabilizers whose conjugation carbonyl structures may cause yellow discoloration, and carbon black, which is the strongest known ultraviolet light stabilizer, of course produces opaque black products in every case. In addition, certain stabilizers may introduce problems of toxicity. Lead, cadmium, and some tin compounds used to stabilize polyvinyl chloride are particularly important in this consideration. Cost of thermal stabilizers is not usually a problem, but ultraviolet light stabilizers are extremely expensive and are therefore used insufficiently in commercial practice. The table 2.9 shows effect of lead stabilizer on electrical resistance of plasticized PVC. So here it is in PHR Try basic lead sulfate per 100 rubber molecule parts per 100 of resin. So per 100 of resin in this case. Volume resistivity in ohms. So you can see here, the more you add it, lead sulfate, the more is its volume resistivity, and then you decrease it, so its volume resistivity also goes on decreasing. Reinforcement and fillers. Solid inorganic powdered films are often added to increase rigidity and decrease cost, and fibrous reinforcement are also added to increase strength and dimensional stability. Addition of fibrous reinforcing agent causes serious processability problems and increase processing cost considerably, particularly when long fillers, woven fabrics, and filaments winding techniques are used. Alkaline fillers tend to hurt electrical properties. Clay fillers may actually improve volume resistivity radically. For example, vinyl electrical insulation. This is probably due to their ability to absorb ionic impurity, which would otherwise have been mobile enough to conduct current. So fillers are nothing but substances that are added in the polymer to reduce cost and increase rigidity. Then carbon black, graphite, copper, and other metal fillers can actually be used in high concentration to produce electrical conductivity. In addition, most reinforcement and fillers have refractive indices different enough from the polymer to make it quite opaque, and many of them also introduce color or at least tinting effects. So the product which will be formed won't have a proper color, it can have some tinting effect like patches on it. Now, cross-linking agent. The use of curing agent for thermosetting resins. Cross-linking agents are for some thermoplastic resin and vulcanizing agent for elastomers is very important for their final mechanical, thermal, and chemical properties, and depends upon a delicate balance between pot life versus rate and extent of cure. They must be carefully chosen to optimize this balance. Most of them causes opacity, means no transparency, and some of them cause color. In addition, some of them are toxic and may be avoided in application where they would be detrimental. So in every additive, he is just in the first paragraph explaining the role of that additive and then how it can be harmful as a final polymeric composition. Then foaming agents. The use of chemical foaming agents which decompose to liberate nitrogen gas is very important in the production of some type of foam. These are quite expensive, and some of them also produce toxic byproducts which must be avoided in certain applications. Very toxic foaming agents cannot even be tolerated in normal processing techniques and require particularly good ventilation. Then flame retardants. We all know flame retardants. Organic phosphates and halogen compound often synergized by antimony oxide and frequently added to polymer to increase their flame resistance. Just a second. At the same time, these additives may lower thermal and ultraviolet light stability, particularly if they use organic halogen compounds. Many flame retardants cause opacity, toxicity as problems as well as and most increased cost. Now lubricants. Lubricants are often added to improve processability and to reduce friction in the final product. They may be liquids or low melting waxes, which exclude to the surface, in which case they may produce poor surface appearance and cause painting problem. As I said, in external lubricant, they extrude to the surface, means they come out to the surface and form a layer, you know, which separates the metal from the polymer, and there is less friction. But this can also cause some problem for poor surface appearance and cause painting problems. Or they may be solid like MOS2, molybdenum disulfide, or brass dispersed throughout the polymer, in which case they cause opacity and sometimes loss of strength. Now, antistatics. We have seen antistatic agents, right? Ionic materials such as quaternary ammonium compounds or hydrophilic materials such as polyethoxyorganics are often coated on finished products or added to the polymeric composition during processing to reduce its tendency to develop and hold a static electric charge during processing or use. Those which are simply post coated on the surface are impermanent. So those who are coated are not permanent. Those which are added during compounding and processing must have precisely the right amount of semi-compatibility so that they will continue to migrate to the surface and replace the superficial material which has worn away during handling and use. This is use. Neither the mechanism nor the technology of their action is well understood. In addition, some of the best antistatic quaternary ammonium compounds have less than sufficient thermal stability and tend to decompose to volatile tertiary amines and produce very undesirable fishy odors during high temperature processing. Now, biocides. In addition of biocides to protect the polymer against bacteria, fungus, rot, and rodents, must not simultaneously produce serious toxicity to humans, because we all know whenever you are using something to kill some insect, that product is very toxic and can also be harmful to humans. That's why we always keep it away. Like if we buy a Mortine coil, it is always said to wash your hands if you have touched the Mortine coils, because they are very toxic, either during processing or during long-term use. This requires a very delicate balance of toxic properties, which is often hard to achieve. Ideally, this should be semi-compatible and migrate gradually to the surface during use, or that they may continue to replenish the surface layer which is being worn away. Some of them harm the color stability of the polymer, particularly during thermal processing. Many of them are expensive as well. Use of elements or groups such as lead, phenol, aromatic hydrocarbons, and aromatic amines introduces problems of toxicity to humans, which must be considered and guarded very carefully. Colors. The addition of colors to polymer is a fine art of blending and color matching. For maximum thermal stability, inorganic colors are generally used, and since these are generally incompatible with the organic polymer, they produce only opaque colors. Development of clear, thermally stable, organic color is much more difficult. Certain color, such as cadmium compound, introduce problem of toxicity. Many colors break down chemically, particularly during thermal processing or ultraviolet light aging, causing discoloration in use. So when you are writing about additives in compounding, so you should mention these topics: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 topics here, and I think so 1, 2, 3, 4, 5, 6 topics here. Total 16 topics you have to write in explaining the monomeric ingredients in final polymeric composition. If you write this 16 points, you get 16 marks. Okay. I know it is tough, but if you read it 2 to 3 times, you will know what is written and you will understand it quite well. Thank you.